In the last lecture, we talked about how select can help you find and retrieve data from a single database table in various interesting ways. But that kind of functionality by itself is rather limited. As we've already seen in relational algebra, to really access the power of relational databases, we need to be able to join information from multiple database tables together through the join. Now, to recall, what a join does is it combines related tuples from different relations, different tables in our parlance today, based on some specific condition that combines them. So, for example, we might combine a customer table together with an orders table based on the customer ID being identical to form a new view of the tables that shows the customers together with the various orders that they've made. This join then gives us access to that combined data, the related data from this table together with that table, which then enables us to do many different useful things. It's really, and this is an important point in general, the linking of data of different types is really where the power of relational databases comes out. So just again, as a refresher, there are different types of joins. There are inner joins, where you're only looking for information that occurs in both tables together, where the linked information comes from both tables. And there are outer joins where you bring all the information from one or the other or both of the tables, even if there is not a linked piece of data in the other table. And we're going to get into this as we see how we do and implement these operations within SQL. We'll start with the inner join. What an inner join does is it combines records from two different tables where there's a common value between the two tables, like we saw a few minutes ago in the customer order example. The basic form of the inner join looks as follows. Select some set of columns, or star, from table 1, inner join table 2. These keywords inner join specify the type of join that we're making. And we also have to specify which attribute, which column needs to match between the two. So we have to specify on table 1 dot common field, whatever the name of that column is, equals table 2 common field. The values in those two attributes needs to be the same between the two tables for that join to take place on a particular pair of records. This syntax implements the equijoin, where the value is supposed to be equal. We'll see other versions in a moment. So as an example, suppose we're looking at a database for a healthcare application. We have patients and we have appointments for those patients. So we want to find, give me all of the appointments for each patient. So what we do is we say select patient's name and appointment date. So we're selecting the name of the patient from the patients table, the date of the appointment from the appointments table, and then we're inner joining from patient's inner join appointments. So we're doing an inner join between the patient's table and the appointments table, such that the patient ID in the patient's table is equal to the patient ID in the appointments table. In other words, we're saying associate each patient with all of the appointments for that particular patient. The result that we will get will be the name of every patient that has an appointment, together with all of the appointments that they have. Any patient that has no appointments will not appear in the result, and any appointments for patients that don't appear in the patients table, which really kind of shouldn't happen, but if there are any, they won't appear in the result either, because we're only going to get those places where, those records where there's a matching record in the patients table together with a matching record in the appointments table. That's an inner join. Now, a special case of inner join is what's called the natural join. In fact, this is an example of a natural join where there's a column that has the same name and the same data type in both tables, and those are the values that we want to match. We can specify that in SQL in a very natural way. We can say select something from table 1, natural join table 2, and that's all we have to say. The system will then determine whether or not there are any attributes that have the same names and the same data types in the two tables, and then require all of those attributes in both tables to have the same values for a match to occur and the combined result to appear in the output. So, for example, suppose we have a patients table that gives the basic information about the patients, and then we have another table that lists all of the detailed information about the patients, their address, their contact information, and so forth. We might do select star from patient's natural join patient details, which then will give us a result that has every patient with all of their details together by matching the patient ID with a patient ID. The more general form of inner join is what we call the theta join, or it's also sometimes called a condition join, because instead of requiring there to be an equality condition between the value of an attribute in both tables, here we allow the condition to be much more general. So theta represents the relationship between the two fields that we're requiring to happen for a match to occur. So, for example, suppose we want to match patients to hospitals where the patient is in that hospital and the hospital is a good hospital. So the hospital rating has to be higher than a certain number. So we might say, well, match patients to hospitals where the patient hospital ID equals the hospital ID. So the patient has been in that hospital and the rating of the hospital is greater than 4. So this is a more complex condition. It's not simply an equality condition. Notice also here, we don't specify that we're making a join or that there is a particular join going on. We just say select something from 2 different tables. This is an implicit way of specifying that we're doing a join. So we'll find all of the records where the condition applies and return those combined records. Another somewhat more complex example. Suppose we have our patients table, and we'd like to find all pairs of patients where one patient is at least 10 years younger than the other. Perhaps we're doing this to do some kind of medical research and we need pairs of patients that are matched, that one is particularly older than the other. Maybe there are other conditions as well. The way that we can do this is by doing a join, which is called a self-join, of the patient's table with itself. So we're looking for pairs of records both from the same table. So we're looking at all possible ways to pair patients with patients, such that the birth date of P2 is less than or equal to the birth date of P1 minus 10 years. And the way that that's represented in the system is there's a function date sub, which is subtraction of 2 dates, and you can specify the interval being some number of days, months, or years. Here we're specifying an interval of 10 years, so the patient 1 birth date minus 10 years has to be greater than or equal to patient 2's birth date. So patient 2 is at least 10 years older than patient 1. And notice what we've also done here is we're renaming the attributes in the output. Because if we left it the way that it was, we would have 2 attributes named name, which would be a little confusing. So we can say select p1.name, so name from P1, which is the first, so to speak, copy of the patient's table that we're looking at in this join. And we rename it as younger patient. The keyword as indicates the renaming. And similarly, we take the name from P2 and rename it as older patient. Again, the keyword as indicating the renaming. So in the result table, we will have 2 attributes, younger patient and older patient. Now we're going to turn to outer joins. An outer join is where we want to retain all of the records in one or possibly both of the tables, even when those records do not have a matching record in the other table. So the way that we specify a left outer join, and the left outer join is one where we're retaining all of the records from the left table, but not necessarily from the right table. It is a very similar syntax to what we saw before. Select from table 1, left join, table 2. Instead of saying inner join, here we say left join. And then we specify which field has to be equal. So on common field equals common field. Table 1 common field equals table 2 common field. This will then return records with the relevant fields from both tables, but in cases where table 1 has a record that does not have a match in table 2, we will have all of the information from table 1 coming through, and then null values for all of the records that we're seeking from table 2. Here's an example. Suppose, again, we want to find all of the appointments for all of our patients. But if a patient doesn't have appointments, we want to see those patients as well and just have null listed as their appointment. Well, here we can do, instead of what we did before, we do a left join. which means that patients that have a matching appointment, where the patient ID matches an appointment's patient ID, will get those patients with those appointments. On the other hand, if we have a patient whose patient ID matches no appointments, that patient will still come out in the result, will still get their name, but the appointment date will simply be the null value. So we'll get all the patients, and if they don't have appointments, it'll just be a null value. In the same way as we can do left outer joins, we can do right outer joins. As you might expect, the syntax is identical. We just use the word right instead of left. So select from table 1, right join table 2 on the condition of table 1 field equals table 2 field. So using the same example again, if we do a right join instead of a left join, what we will do is we will get only the patients that have appointments, but if there are any appointments that don't have a matching patient for some reason, those appointments will show up with a null patient name. This might be a way of debugging the database in some fashion. We can get it out and see which appointments are left hanging and delete those appointments or fix our system or what have you. Finally, we have what's called a full outer join, in which we want all of the data from both tables, whether or not there's a match on either side. So as you might expect, instead of saying left join or right join, we say full join. Select from table 1, full join table 2 on table 1 field equals table 2 field. In this case, if there's a record in table 1 that doesn't have a match in table 2, we will see it with nulls for table 2 fields. If there's a record in table 2 that does not have a match for table 1, we will see it in the result with nulls for the table 1 fields. So we'll get all of the data in the output. If there's a match, we'll see the matches. If there isn't a match, we'll get nulls on one side or the other. So using our example again, if we select patient's name, appointments, appointment date from patient's full join appointments, what we will now get are all of the patients and all of the appointments. If there's a patient who doesn't have an appointment, they will have null for the appointment data. If there's an appointment which somehow doesn't have an associated patient, it will have null for the patient name. To summarize, joins in SQL are a fundamental operation here in relational databases. They're the operations that allow us to retrieve data that links multiple tables together. So different tables will represent data about different entities or about relationships between entities, as we will see as we move on. And being able to select data from multiple tables simultaneously while doing these joins allows us to find the data that we need efficiently and effectively. Once you've grasped the basic concepts, practice is important. It's important to understand and to practice the different kinds of joins, seeing what kinds of results you get, and feel comfortable with inner joins of different types and the different types of outer joins so that you can design complex queries and manage appropriately the relationships between different database tables and the data. As we continue to dive into SQL, we will see more ways of putting together these fundamental operations and principles into more complex and more useful forms.